Now, welcome back. And today we're going to be digging into the Module 2 material that you've started to go through. But before I get started with the stuff that I want to say about that, does anyone have any questions about the material that we've gone through so far, or anything you learned about in Module 2 or the second assignment, which is going to be due next Wednesday at midnight? Like several of you also asked about the how the auto grader works with respect to your first assignment, and so I'm happy to answer any questions about that. Although I also posted some additional info on our Gitter channel in case you want to take a look at that. Anyways, any questions before we get started with the main content for today? Nothing, just shaking heads. Okay. I also want to note I've been posting updates about the recorded lectures to the Gitter channel. So if you are not already on Gitter or haven't already joined the Gitter channel, I would recommend doing that. Okay. Wonderful. Okay, so let's start with Module 2. So the first concept that was covered in Module 2 is the text-based user interface, or TUI, which is sometimes pronounced TUI. And then the main new thing there is the input function. So can anyone tell me about what that function does, or like why it's useful? What does input do?
It allows the user to enter something in the command line, so a line of text, and then you can store that as a variable.
Yeah, totally. Let me actually share my screen. Was it helpful yesterday or Wednesday when I showed you demos as I was talking? Okay, I'm going to do that.
That's really helpful.
Okay. All right, let me size everything. Okay. Okay, so let's see, I'll write a little input demo. All right, so sorry for the soundtrack here. I don't know if you can hear that. My 3-year-old is doing some baking in the background. Very exciting. Okay, so I could type answer the question, what is your name? And then I could type my name, Jeremy, and then it'll say, so once I type my name, the input function completes and returns whatever I typed in and assigns it to the variable name. And then in the next line, and then that line is now done. And then in the next line, it prints out this string that I specified. So these are F strings, which are very useful. They allow you to enclose expressions in curly braces, and then whatever is evaluated, whatever gets evaluated by that expression is turned into a string or cast into a string, and then inserted into the rest of the string that you specify. So these are really useful. Okay, and then it prints out hello and then the name that I typed in, Jeremy, which is also my name. Okay. So since this course is focused on applications to psych research, it's worth thinking about how you might use the input function in your experiments. So if you have some sort of user interaction component in your experiment, like, where the participant needs to press a button or like type out responses, then one way to do that is with the input function. Okay. Any questions about input? Pretty straightforward. Okay. The second tutorial in module 2 is about control flow and order of operations in Python. And so we had gone through a few of those ideas earlier this week, but I wanted to highlight a few things that we haven't specifically touched on in class yet. So first, let's write 2 blocks of code that are going to look pretty similar, but then we'll try to understand how they're different and why that's important. Okay, so let's get a variable x, which we'll assign to 10. Okay, and then we'll make a bunch of if statements. Okay. As I'm typing this stuff in, if something doesn't make sense, just let me know. I'll try to do a little sampling of things that might be useful. And let's see, I'll have. Okay, so first of all, like I've visually differentiated the statements that are true versus false here. So things that are true, I've made end in exclamation points. And then things that are false end in ... That's not a Python thing that's needed. It's just to help us see this example. Okay, so when I run this, who can tell me what's going to happen? What's going to be printed out, if anything? It's going to crash.
X is 10 and stop.
X is 10 and then stop. Let's see. Wonderful. Okay. What about if I change these elifs to ifs? What's going to happen?
So then it will check all of them. So you'll get x is 10 and bigger than 5 and x is even.
Yeah. And there will be one confusing one also.
The X isn't any of these or those because of the last.
Yeah. So this is kind of weird. So these look super similar, right? But this else gets attached to the most recent if statement that it's kind of appended to. And so if this if statement's argument evaluates to false, which it does because x is not odd, then this else statement runs. It doesn't care about the other if statements. Okay. So I mentioned this because because these look similar, this can sometimes lead to accidental issues in your code, and it can sometimes be confusing if like an else statement in a long block runs even though one of the earlier conditions was true. So something to watch out for. Another thing this kind of highlights is that you can see that like if you organize your if, elif, else statements so that like the things that are higher up are like quicker or like easier to compute or simpler or more general or whatever. Well, I guess sometimes you might want them to be more specific and other times more general, but if you can organize these statements so that some of these conditions only run if they are needed to, like if like none of the other conditions work out. And if one of these, like if the body of one of these elif statements, for example, took a really long time to run, then it'd be nice to be able not to run it unless it was like strictly necessary. And so the like if elif syntax can be preferable in that circumstance. Another thing to think about is like, is elif strictly necessary, or like could you approximate it with just else, like if and else statements? And if so, how? Okay, who thinks elif statements are necessary? Raise your hands.
Could you say necessary to accomplish what?
Could you write? Well, that's a good question. That's fair. So what I mean is like adding elif statements to our vocabulary gives us access to some like functionality in Python, right? Or like expressiveness in this language. The question is, are there some like concepts, so to speak, or like programs that we could express with elif that we could not express solely with if and else? Like, can you think of any examples of programs that like you need elif to write them and you just couldn't write them if you only had if and else? Or is it just kind of a convenience thing?
You could simulate an elif string just by like continually nesting if statements underneath else statements, right? It would just be horrible eventually.
Yeah, exactly. So I could that's right. So if I wanted to, I could say this, right? And then well, I'll just type it out because it's worth doing it one time to show how annoying it is. Oop. Okay. So those are functionally equivalent now. But you can see how this is like, could get unwieldy. Okay. Any questions on that? Wonderful. Okay. Moving on. So sometimes it's useful to tell Python to specifically not do something, like to do nothing. So can anyone tell me what the pass or continue or break keywords do, or like why they might be useful?
Well, the break keyword would be useful if you have a while loop that you didn't specify an end for, or you're trying something out and you want to make sure that you don't have to, unplug your computer to stop it from going, or so it'll break it
Yeah,
at
yeah.
a big point if you want to debug something or so.
Yeah, so you could say like, so this would be like an infinite loop. Okay. Oh. Let's see. Okay, yeah, so even though it's an infinite loop, once this condition is satisfied, it'll break out of the loop. Okay. Yeah, that's a nice use. Okay. So that's the break keyword. What about like pass? What does that do?
It's good if like you want to, like you just want to skip one iteration of the loop, so like you don't want to leave it completely, but there's some condition where you want to.
Close. That's the continue
Or is
keyword.
that the continue?
Yep.
What did pass do again?
So pass literally does nothing. So why would you want that? Anyone have any guess? There's even a psychology experiment reason why you might use this. Yeah. What if I wanted to write like a timer? So, okay, so this date time module, well, let's first see how it works. So, okay, so this prints out like the current date and time, as you might, I mean, it's somewhat, yeah, as the name implies, right? And then if I run it again, it'll update that, okay? So it's, what is the time now? That's the question answered by this function. We could write a function like sleep some number of seconds, and then we could start a timer when the function enters, and then say like, while the current time minus that start time is less than some amount, then do nothing. And then that's the whole function. Okay, so then we could say like print hello, sleep 3, print goodbye. And it'll wait 3 seconds before printing goodbye. Or if I said like sleep 1, it'll only sleep 1 second. So, if you have some sort of experimental timing in your experiment, that could be useful. And if you don't want to do anything as you're kind of waiting for the next thing to happen, then the pass keyword is a nice way of kind of acting like a placeholder. So if you didn't have the pass keyword, like this is not a valid while loop, and neither is this, but pass enables you to satisfy the requirements of Python syntax by having a body of the loop, even though it doesn't actually do anything. Okay. Okay. Okay, and then so continue. now I'm forgetting who said, someone mentioned continue. Yeah, so it's like, it's gonna skip over the rest of the body of the loop that you're in, and then continue on with the next iteration of the loop without running the rest of the body. Let's see, let's make a silly example. Okay, let's use the NumPy library. We haven't done that much. Okay. Oops. Oh. By the way, I should point out what I'm doing. So Collaboratory has code completion, but it doesn't run if it doesn't know what you're typing. So like, I hardly ever memorize the different modules in the different libraries. So like, I basically don't know them. But if I'm like, oh, there's some random library, like if you type np dot after you've run this line, then it'll like list in a drop-down menu all the functions. And I'm like, okay, it has something, I don't remember if it's called rand or random. But then as I start to type it in, it'll like narrow down the choices. So that's what was happening there. That's often useful. Okay, and then I want like random integers, okay. And then it'll tell me how to use this function. Okay, so I want them to be like between 0 and 10. And then let's print out like 100 of them. Okay. So this is going to give me like a list of integers between, well, it's actually 0 and 9. So one less than this value, inclusive, or between 0 and 9 inclusive, not inclusive of 10. And then it's going to give me an array, which is like a NumPy version of a list that's 100 elements long. So this is 100 kind of random integers between 0 and 9 inclusive. Okay. And then we could make a function. Okay, so we're gonna okay, so let's, oh, maybe I can tell you about some other functions too. So let's this is kind of going to be a silly example. Let's write a function where we're going to get like the any values that are repeated in the list that we pass in and the index of the first time that we get a repeat. So like here, 2, well, it's the first element, so that's not a repeat. 4, well, it didn't appear before in the list, so that's not a repeat. But this 4 did appear in the list, so that's a repeat. So we're going to return 0, 1, 2. And then, etc. Does that make sense? Okay, so let's keep a list of the repeated things and then the like indices. Okay, so this is kind of a cool function, enumerate. So what enumerate does is it wraps what's called a Python iterable, which, well, we learn about later in module 2, but I guess haven't officially learned about it in class yet. It's something that you can like chunk through each element of the thing in turn. And a list is an example of this. A range is another iterable. I think Python even has, let's see. Can that, no. Okay, whatever. There's some way to check if something's an iterable. I don't remember it off the top of my head. Anyways, the enumerate function wraps iterables like lists or arrays, and instead of just returning the elements of the array, it also gives us the index of each element starting from 0. So it'll go like 0, 1, 2. And then I can use this syntax here to get, like each time I go through this for loop, the I will be set to the element number or the index of that element, and V will be set to the value of that element. I don't have to call them I and V, but I'll just call them that here for I don't know, convenience. Okay, so if V, the value of this item on the list, is already in repeats, then we've already found V, and so we can just continue and look at the next number. So we've used the continue keyword. Okay, otherwise, if V is in anywhere up to but not including the ith element of the list, then we're gonna append the value of that item to the repeats list, and then we'll append the index of that. Sorry, Anna, did you have a question?
Yeah, just I think that you initialize repeat and then you're calling repeats plural.
Thank you.
Yep.
Would have been a disaster. Would have crashed the entire internet right there. Yeah, no. Okay, and then we'll let's return. Why not? Return that. Okay, so okay, so here are the things that were repeated in the order that they're repeated, and then here are the indices, and then we could actually check our there's another actually nice way to do this. Yeah. Well, it's skipping ahead a little bit. Okay, well, it'll look like magic right now, but it's sure, why not? Okay. Oh goodness. Okay. We'll talk about how that works. Okay, so this is the enumerate function again, and remember it goes through a list and returns both the values and the indices. And the way it does that is with these little, they're called tuples. It's like it packages up the index of the thing with the value of the thing. And then this magical line here is called a list comprehension, which we haven't gotten to quite yet. And that is a convenient way of making a list like this. And we'll go over the syntax later, but what this function does is it makes a list where of these tuples where the first elements in every tuple are the indices. So it'll go from like 0 to 99. And then the second elements of each tuple are the values. So if I go to, so if I like print out the values, it'll go like 2, 4, 4, 5, 6, 7, 2, 4, 4, 5, 6, 7. Make sense? Okay. So now we can check to see whether this works. Okay, so 2, that's not a repeat. 4, that's not a repeat. 4, okay, we have a repeat, and it's in the second position. Okay, so 4, and it's in the second position, so that's working. And then 5, not a repeat. 6, not a repeat. 7, not a repeat. 6, oh, we've seen that before. So 6 and 6 should appear, etc. Make sense? Okay. All right. Now, what are we going to do for break? Let's see. All right. Well, I'll do another silly one. Okay, so let's make a function that returns the first like up to the length of the list, elements of the list, until the sum of those elements hits some threshold value n, and then skips over everything else. Or if you never reach n, it just returns the whole list. Okay, so does that make sense? Okay, and like for simplicity, we'll assume everything is like non-negative, and we won't check data types and all that. Okay, so we have some sum that we have a sum that we are going to keep track of, and here are the elements that we're going to store, and then for each element, we're going to increment by the sum by that element, and then if the sum is greater than n, then we'll break and stop going through this loop. And then otherwise, we'll append I to the list. We have a mail truck coming. That's also very exciting. See, if you're 3, lots of things are very exciting. Okay. Okay. So, well, why don't we just use the same? Does that make sense, everyone? Okay, so let's, I don't know. Well, let's make it sum to 20. There we go. Does that sum to 20? 6 plus 4, that's 10, that's 15. So what is, let's see. Oh. Yeah, that would have, yeah, so a 6 is bigger than a 5, so that would have got us over 20. So that seems like it's working. Okay. Now, if our list was like, 100 million items long, this break would have now saved us a lot of time. Okay. So, like it's worth thinking about how these might be used in experiments. So like timers are pretty common, like I said, so you might want to like display something on a screen and like then wait for 3 seconds and then clear the screen and then do something else. Or like you might want to wait until the user presses a button or responds in some way. And then the like continue and break keywords let you break off execution of the body of a loop before it's done. So if the body of your loop is set up to like get your experiment or analysis 1 increment closer to some condition, then once the work of the loop is done, or like once you know the rest of the loop won't be relevant, the continue keyword can like save a lot of time by skipping over stuff that you know won't be needed and then continuing with the next iteration of the loop. And then similarly, the break keyword also stops execution of the rest of the body of the loop. But then instead of continuing with the next iteration, it just entirely exits the loop and doesn't run any more iterations. Okay. Any questions on those? Those are super useful. Okay, great. All right. Okay, so the next kind of big idea is related to errors and warnings. Like, how do we handle times when our code doesn't do what we want it to? So there's this poem called the Zen of Python, and you can view it by importing this. All this like the library this does is it prints out this thing. So it's actually like gets at the philosophy of like the design of Python and like what writing good Python code is, but it's also kind of silly. But of note, where are they? Let's see. Oh yeah, errors should never pass silently unless they're explicitly silenced. So yeah, that's important. So in the software engineering world, a lot of thinking is done around how to handle crashes or failures in code. And there are a few fundamental principles. So first, there's the idea of failing well. So it's not possible to write code that will never fail under any circumstances. There are too many circumstances or infinitely many circumstances to actually prove that. So you have to assume that your code is going to fail. But when your code fails, it'd be better for everyone, perhaps especially you, if you've done your due diligence to minimize the fallout of that failure. And so that's what failing well means. And one aspect of failing well means that when a failure happens, ideally the failure should not bring down your entire system or analysis or experiment. So if you imagine that, your first job after you graduate is writing some sort of security software for a bank where the user is supposed to enter a password, it'd be really, really bad if the entire security system just crashed or failed or turned off if the user entered a letter instead of a sequence of only numbers. But a better solution would be for your program to print out a warning or an error message explaining that the input was invalid, and then either lock the user out or ask them to enter their password again or something like that. Or if you're for example, running an fMRI experiment and your experiment misses a sync pulse from the scanner that you're expecting, ideally the entire experiment wouldn't crash, but instead maybe you might want to print some sort of error message to a log file or pop up a warning or something like that. Okay. And then a second fundamental principle in dealing with crashes or kind of errors is called failing fast. So failing fast refers to the idea that you should try to detect that your code will eventually fail as early as possible in the code's execution. So if you're running an analysis that takes 10 hours to finish, then it'd be a lot more convenient for you to check that the data you're analyzing passes all of your sanity checks before you run the time-consuming part, versus only finding out after you wait 10 hours that your analysis is returning all zeros or some kind of nonsense result. Okay, so with those ideas in mind, let's talk about how to handle errors and warnings in Python. Okay. So if you know that some part of your code might crash under certain circumstances, then you can wrap that code in what's called a try except statement to help your program deal more gracefully with that crash. So a try statement attempts to run some code, but then if the code crashes, it immediately stops executing. And then if it exists, if an except statement exists, then it begins executing the body of the except statement. So a common one is divide by zeros. So we can't divide by zero. That's not allowed by the gods of math. Okay. So it doesn't crash, right? We just get a little print statement. That's not so bad. Okay. And then, yeah, so there are, you can also tag except statements with a specific type of error, which is good coding practice. So if you're specifically looking for errors related to dividing by zero, we can look up what that error is. And there may well be a systematic way to look up what the different types of errors are, but the way that I do it in practice is kind of janky. I force Python to undergo that type of error. And then I say, okay, Python printed out, like look at the error log and say, Python just threw a 0 division error. And now I know that that's what kind of error it is. So didn't have to look anything up. So then like I could specifically now tag this except statement with a 0 division error. And if like there was some other type of error, like it'll still crash. Okay, so that's like a nice. Remember how I was kind of railing on MATLAB in R like a few days ago, and I was saying like, well, they're like almost too friendly because they like allow, they're too robust in a sense. They allow anything to run. Well, try statements are a way to like make Python have that same problem. You really want to like predict what your error will be and then handle that specific case. And that will help you avoid like accidentally going into an except statement that like at a time when you didn't think you would need to be there. Okay. Oh, and then you can also like string except statements along, kind of like elif statements. So, oh, sure, environment error. Let's see. Okay. Okay. Great. So Python has a gazillion types of errors, but you might want to do different things depending on the specific type of error you get. And so when you include like a type of error next to the except statement, it will only run that statement if that's the specific type of error that caused the try statement to exit. Okay. Okay. Make sense, everyone? Okay. Another modification for try except statements is using the finally keyword. Yeah, so this one's a little tricky. So if the try statement executes successfully, then actually, you know what? It runs either after. It runs either for a try or except statement. Okay, let's see. Let's see if I can. I'll make a little demo. Sorry. Okay. Oops. Okay. Okay. So what this does is it's like a statement that is guaranteed to run no matter what else happens. It's like the final say on something, which means that anything that causes a try or except statement to exit, which is usually, like in the most basic case, it's like a return statement. So returning something typically causes the whole function to exit and doesn't run anything else below that. But if you were like inside of a loop and had a break or a continue that caused your like try except statement to prematurely exit, then finally would also like supersede that line. And what happens is that whatever you type in, or like in the body of the finally statement, which could be its own return statement if you wanted it to be, but doesn't have to be, gets run before that last line of the try statement or the except statement. You know what? Why don't I make this a little bit cleaner? Okay, so let's start with something that I'm allowed to divide. Okay. So let's walk through what happened. So I passed in 1 and 2. I'm perfectly able to divide 1 by 2, so that's allowed. I assign it to the variable result. And then the next line is return try, the string try. But if I ran this line, that would cause the entire function to exit. And so what happens is the body of the finally statement runs first. And then, since there's no return statement in the finally block here, the return statement of the try block runs after, and the value, the string try, is returned. Okay. Now, if I pass it, like similar, the same thing will happen if I, instead go into the except condition. So if I divide by 0, this line throws an error, which is specifically a 0 division error. Then I go into the except statement. And then now I'm going to return except running that line would have exited the whole function, or this whole block. And so first the finally statement runs. Does that make sense? Okay. Now, weirdness can happen if this was a return statement, because return is also a perfectly valid statement. And what that will do is it will like short stop whatever return statements are in the try or except statements. So like if my try statement returns a value, I can overwrite that with the finally block. Can be kind of confusing.
Wait, so would it do the same thing if these were breaks, or if it were in a loop, if there were a continue?
Well, you're not allowed to have a break or a continue outside of a loop, but let me just show you that. Yeah, so this is actually just going to crash totally. Oh, it didn't even compile. Syntax error. Yeah. And same thing with continue. Yeah, because there's like no loop to break or continue. But you can have a try statement or a try block, try except finally, etc. block inside of a loop, and then you can use break and continue. And so that's like the situation that finally would get triggered on or before. Okay. So the finally keyword is useful if you have like some condition that needs to run regardless of whether or not the try or except statements ran. So like if you're collecting data from a participant and some measurement fails to register, or like the experiment glitches or something like that, you might still want to log what happened. Or if you're like reading from a file and might encounter an error if you have like a corrupted file or something, you can use the finally statement to make sure the file is closed before like the code block finishes, and that'll help you not like leave an open file descriptor hanging, because that could lead to like further data corruption or other issues. Okay. And then another useful modification is that you can actually use the else keyword also in try except statements. And so the else block runs if and only if the except block does not run. And then like with the try and except blocks, the body of the finally statement, if it exists, runs before the return statement or break or continue in the else block as well. Okay. Let's see. Oh, and if there's a break or continue or return statement in the try block, then the else block won't run because the execution of the full set of statements will have ended in the try block, or possibly the finally block if that exists. So the else block only runs as an alternative to the except block. Okay, so let's see. I'll make up another example. Okay. So okay. And then, else, okay. Return else. Okay. So let's explore this. Okay. So okay. So if we have a divide by 0 error, we start by trying the try block. We run this line, it prints out this statement. Next, we try to execute this line, it throws an error. The type of error it throws is a 0 division error. So now we enter the except statement, which runs. Then it sets result to this. There's a return statement, which would have exited the function. So instead of running that, we run the finally statement and return the string finally. Okay. But let's suppose some other type of, like we tried to catch some other type of error. Now the except, well, let's see what happens. Ooh. Well, I would have expected this else block to run. Let's see. Maybe what does this do? Aha. Oh, right. It just crashed. Okay. Okay. Okay, right. Yeah, so the body of the else statement is not protected from crashes like the body of the try statement. So if there are exceptions raised in the else block, Python will just crash just like it would if you didn't have a try except statement. Whereas like if you have an exception raised in a try block, as long as it's covered by one of the exceptions that you specify, or you just don't specify an exception, in which case it just looks for anything. If you do this, Python will just happily continue on with the except or finally statements for the rest of your program. I'm actually having trouble now thinking of like a example that will trigger the else state. Can anyone think of one off the top of your head? Okay.
Can you put a try within the else statement? To
Yeah,
catch?
yeah, that's valid. Yep, you can nest these. Yep. Mm-hmm. Oh, this is another, so that I think you can do that. Oh, okay. Yeah. Okay. Yeah, so some languages let you have a try block. In some languages, this is called try catch, but in Python, it's called try except. Some languages let you have a try block without an except block. Python does not seem to like that. But you can simulate not having an except block if you just have pass be the body of the except statement. So it does nothing if there's an error. Yeah, and this will effectively waste a tiny bit of time as your computer tries to divide by 0 and then throws an error and then does nothing, but it won't interrupt the flow of your program. So you can include that if you really wanted to anywhere you wanted, and it wouldn't change the functionality of your program. Okay. Okay. The other, oh, sorry, any other questions about try, except, finally, else, that whole thing? Okay. To be honest, I don't remember off the top of my head ever using the else component of these statements, but you can use them if you so desire, if you think of a use case. But try, except, finally are definitely useful. Okay. Okay, the other type of like error handling mechanism in Python is kind of like a soft version of errors, and they're called warnings. Warnings are kind of like print statements, but they're intended to specifically tag potential problems. But unlike, oh, I'm sorry. There's one, sorry, before I talk about warnings, I wanted to mention one more thing about exceptions. Sometimes it makes sense to actually manually trigger a crash. Like if you test something and you want your program to crash. So like I mentioned, failing fast is sometimes good. So like, some sanity check didn't pass. You can raise, you can throw an error, or it's called raising an exception using the raise exception, or raise keyword. And then you can type like an error message here. So like, I did a bad. And then it'll crash Python dutifully and print out your error message along with a stack trace. Okay. And then you can even, let's see if this works. Yeah, so you can like do that with any type of exception. Okay. Okay, right. Yeah, and so, okay, so warnings are like soft versions of exceptions in that they don't halt the execution of your program. So there are two things that I usually do with warnings. So first, to gain control over warnings, you have to import the warnings library, which you do like this. Thing one that I do with warnings is if you encounter some situation where you want to print out a warning, you can use warnings.warn and then do not continue. You know, and it'll print out like a line where the warning was triggered and you know, your message that you specify. Okay, and then the second, so it acts functionally just like a print statement, but it prints out like where in the code caused that warning to go, to trigger. And then the second thing that I do with warnings typically is to suppress them, which is kind of like the opposite of using warnings. And to do that, the simplest thing to do is using this simple filter command. So if you type simple filter ignore, I mean, it doesn't do anything if you just type it, but if you encounter a situation where a warning would have been printed, including this statement before it, or like technically within the same scope as that statement, we'll learn about that hopefully on Monday, or as you go through the rest of module 2, then your warning messages will be suppressed. Okay, so we're about out of time for today, but are there any questions about anything we've gone over so far today, like input statements, control flow, error handling, anything else? Wonderful. Okay. Okay, so for Monday, please go through the rest of the module 2 material, and we'll start on Monday, like going over any questions you have on the material or the upcoming assignment. And then we'll continue reviewing like dictionaries and classes and variable scope and passing by value versus by reference, and also like some useful special syntax things that you can do in Python. And then also remember that assignment 2 is due this coming Wednesday at midnight. So please check that out before then so you can ask any questions like before the last possible minute. Aside from that, have a wonderful weekend and I will see you on Monday.